Hello, welcome back to Cinderella Math. Today I'll be doing some trig identities. So this is probably best for people in pre-calc or if you're in a standalone trig class. Maybe if you're in advanced algebra 2, but probably gearing toward my friends in pre-calc. This piece of paper that I'm going to be pulling problems from was sent to me by one of my private tutoring students. So I'm not going to project it to the screen because she put her name on it, and of course I want to preserve her privacy. But it is, let's see, one, two, three, four, five, six, seven problems of verifying trig identities. So I just actually did a video on simplifying trig identities. What's the difference, you might ask? Verifying, they tell you the answer, and you just have to show how they got there. So go ahead, grab pencil, paper. You probably do not need a calculator, but what you will need is a formula sheet for the trig identities. Either your teacher or your professor gave you one, or just Google and find something that says trig cheat sheet, trig formula sheet, and we're going to be focusing in on identities today. All right, I have been having some problems with my magic pen here. Hopefully this works okay. Yeah, let's go ahead and get started. So again, I think I'm going to be doing about seven problems. The numbering is going to be a little off because this is actually the second page of my student's paper. So if you are that student or you have that same paper, the directions are for the following problems, verify the identity algebraically. And we are going to start with number 9. Okay. So again, it's really number 1 of this video, but on my student's paper, it's number 9. All right, here is what 9 says. Cosecant of theta over secant theta plus cos of theta over sine theta. And we need this to equal 2 cotan theta. So the rule of thumb when you're doing a verify problem, again, we already have the answer. The rule of thumb is you're going to pick the more complicated side to mess with. So for us, and usually that'll be your right-hand side. All right, so just looking at the right-hand side of this one, we can't add these. They don't have a common denominator. So this one has sine, this one has secant. So let's invite onto the denominator sine to our left-hand side, upstairs to be fair, and let's invite to the right-hand side secant, upstairs to be fair. So on the top, we now have cosecant sine plus cosine secant all over one big denominator because we got a common denominator of sine secant. All right, you can either go to your cheat sheet or some of these come up so often you might have them memorized. If you do need to refer to your cheat sheet, it should be in a section called reciprocal identities. We know that 1 over sine is cosecant, right? The reciprocal, the flip of sine is cosecant. So this cosecant right here on our top left of our equation, we're going to change that. We're going to change that to 1 over sine, and then we still have sine, plus we have cosine, and then we also know, back to your cheat sheet if needed, we know that 1 over cos is secant. So this secant right here in the top right of our equation, we are changing to 1 over cosine. And then let's just leave the bottom alone. So this is sine and secant. Okay, some cool stuff is going to happen on the top. Sine cross cancels sine, cosine cross cancels cosine. So that leaves us with 1 plus 1 over sine secant. So that is 2 over sine secant. Okay, but sine on the bottom, go back to our little cheat sheet here. I'm putting a star beside it. Sine on the bottom is cosecant. So this one's going to flip up, and now we're going to have 2 cosecant over secant, and then come back to your cheat sheet, 1 over secant. It should still be under reciprocal. What's the flip of secant? Well, that's cos. So flip up this secant. So final answer is going to be 2 cosecant theta cos theta. The order can be changed, by the way. You could have 2 cos theta cosecant theta. It doesn't matter because it's multiplied together and multiplication can be any order. Oh, but that is not what we were actually proving. Lies, 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 lies. So take that back right there to the very last black line. I'm going to put this actually in a green box. That's not the answer we want. Look up at the very tip top. We want 2 cotan. Okay. So let's actually revert cosecant right here. Look to the one that I have the black star. I'm going to put a green star. Cosecant is 1 over sine, yeah? So let's revert that back. So this is going to be 2 times 1 over sine times cosine. Okay, I'm going to come right here in the green. So that would be 2 cosine on the top, sine on the bottom. And then back to your cheat sheet, or this comes up so often you might just have it memorized. This would be under the quotient identities. Cos over sine. That is the definition of cotan. So right here, this cos over sine, that's going to be replaced with cotan. So we're going to have 2 cotan theta. There we go. That is what we were trying to prove. All right, that was number 9, really number 1 for this video. All right, let me just let that be up there for a second. And then if you're still copying or still digesting that, pause me. Okay. Alrighty, this will be our second one for this video, second verifying number 10, if you're my student who actually sent me in these problems. And here's our next one. I'm going to just clear this. Number 10. 1 minus sine squared theta over 1 minus cos theta needs to equal negative cos theta. And again, we're going to pick the right-hand side, the more complicated. I know this has an invisible 1 in the denominator. And now we cannot subtract these, right? We need a common denominator. So we are going to invite 1 minus cos to top and bottom. Okay, so let's distribute this 1, or 1 times anything is just itself, right? So that would be 1 minus cos minus sine square. Okay, so that's the top now. And the bottom common denominator was 1 minus cos. Ooh, all right. So again, come to your cheat sheet and let's think about our Pythagorean identity of sine square plus cos square is 1. What if we move this over? Cos square is 1 minus sine square. Now, we don't have that exactly, but we're allowed to change order, so we could just switch these two. Let's change the top of this to be 1 minus sine square minus cos. We are allowed to change the order. That's okay. And now we have 1 minus sine square, 1 minus sine square. We're going to make that replacement using the Pythagorean identity. This 1 minus sine square is going to go out, and we will replace it with cos squared. So we now have cos square minus cos on the top, and on the bottom we have 1 minus cos. On the top, I see a GCF. They both have a cos. So let's pull that. We're pulling cosine. So basically, we're dividing by cosine. So that would leave one cosine. And divide by cosine. That would cancel and leave minus 1. All right. So you might be saying, oh, yay, we can just cancel this and be done. Kind of, sort of, maybe-ish. Um, Let me just talk a little bit about arithmetic for a second. If you're subtracting, but the things are switched, so example, you don't need to write this down. Say you have 7 minus 3. Well, that's 4. But what if you have 3 minus 7? That's negative 4. So when we were subtracting and we changed the numbers, yes, we got 4 both times, but the second one's negated. So this is just a rule. You probably learned this in Algebra 1 or Algebra 2, but let me remind you, if you have fraction A minus B and then it's over B minus A, so it's basically you're subtracting the same things, but they're switched, you can cancel that and it is negative 1. Because look back up to my example with the 4 and negative 4, you would just negate this by timesing by negative 1. So looking back to our problem, we can cancel the cos minus 1 with the 1 minus cos, and we replace it with negative 1. So we have cos theta times negative 1. This would just look better in the front, which would be negative cos theta. So we need a little bit of algebra rule in there as well, more than just a trig. That's what makes these so hard. And we have now verified it. Okay, that was number 10, second one for this video on verifying. Going to my student worksheet number 11, third one of this video. Now this one's got a rule that we have not done, so I'm actually going to go to my cheat sheet so I can show this rule when we need it. Okay. So we're going to need what's known as our even and odd rules for this one. And again, this is number 11 off the student's worksheet. These I don't even memorize. I just kind of always refer to them. They do come from unit circle. Like you can derive them if you need to. So if you do have a teacher that doesn't let you use a cheat sheet, you can get them with relative ease, but it's nicer if we just have a cheat sheet. Here's number 11. It's cotan of negative theta over cosecant. And we want to prove that this is negative cos. So again, we're going to start with our right or left-hand side, which is the more complicated one. I think I've been saying right-hand side. I'm sorry, I'm losing my mind. It is mid-December, so as a private tutor, I am in exam mode and my mind is just going. I apologize. We're going to start with the left side, and that's what we've done on the other ones as well, the more complicated side. All right, but I don't want negative theta. So if we look into these even odd formulas, right here, there's cotan negative theta. It just can be replaced with negative cotan theta. Okay? I think on this particular student who sent me the papers, on her cheat sheet though, she only had the sine and cosines. So I'm going to pretend like that's all we have. Okay? So we could scroll up on this sheet, but I have already whited it out. But that's okay. On your sheet, if you come to quotient identities, or you might just have this memorized, cotan of some angle is cos over sine. So looking at ours right here, our top, I'm going to change our cotan into cos of negative theta over sine of negative theta, and then that's still over cosecant. Okay? And again, the reason I did that is because this particular student who sent me this in on her cheat sheet, she only had these two. So now using the even odd we have cos negative theta. Cos negative theta is cos theta. So this top is now cos theta. And then we have sine negative theta. So using sine negative theta, we have negative sine theta. So that's using the even odd, and it's still over cosecant theta. Okay, but go to your reciprocals, or again, you might just know these. 1 over cosecant. So cosecant on the bottom is the same as a sine on the top, right? So flip this up to be a sine. So that'll give us cos theta over negative sine theta, and this has flipped up to be sine theta. Sine theta will cross cancel, and we're left with cosine theta divide negative, so technically negative 1. Cosine divide negative 1 would be negative cos theta. Boom. And we have proved it. Alrighty. Number 12. This one doesn't look too bad at all. Not an even and odd. Those don't come up too often, by the way. I would not stress those. Here's number 12 on our verifying practice. Sine theta plus cos theta cotan theta needs to equal cosecant theta. All right, well, this one's fine. Keep the plus, cos is fine, and then go to your cheat sheet, or you just know from your quotient identities that cotan is cos over sine. That is a good one to memorize if you can. If not, just go to your quotient identities. So we're replacing cotan with cos over sine. Okay, so now we have sine plus cos times cos would be cos squared over sine. This is invisible 1. We need a common denominator, so we'll invite sine, top and bottom. Sine times sine would be sine square plus cos square all over the denominator of sine, because that was our common denominator. Pythagorean identity, sine square plus cos square is 1. So the top of this is 1. So we have 1 over sine. And again, you either know this next part or you come to the reciprocal identity. 1 over sine is cosecant. So this will flip up and be cosecant. Ugh, the pen, sorry. Doesn't like C's. There we go. Answer and prove. That was 12. Coming to 13. All right, we have cos over 1 minus sine equals secant plus tangent. Alrighty. The rule of thumb is you start with the more complicated side. They honestly look about equal complicatedness, but probably should go with the fraction. So just looking at our left-hand side, and you might be saying, well, hey, it's just one fraction. Like we don't even need a common denominator. This is going to be a new strategy that we have not used, and it's going to be called multiply by the conjugate. And again, you might have heard of the conjugate before. What it is, if you have A plus B, the conjugate is A minus B. And if you have A minus B, the conjugate is A plus B. And we usually use the conjugate of the denominator. Okay, so we are going to multiply by the bottom, the denominator's conjugate. So we're going to keep the 1, we're going to keep the sign, and we're going to flip that to be a plus. And we're going to do that on top and bottom because we got to be fair. Okay, so on the top, we just have cos times that conjugate. And on the bottom, we can gonna go ahead and FOIL these out. So 1 times 1 is 1. 1 times sine would be sine. Under would be negative sine. And under would be negative sine squared. These two, sine minus sine, cancels. So we now have cos 1 plus sine on the top. And on the bottom, we have 1 minus sine squared. Okay, but again, Pythagorean identity. Sorry, my pen is just driving me nuts. Okay, Pythagorean identity. We know that sine squared plus cos squared is 1. And if we move this over, cos squared is, sorry, this pen is just going. I think I have troubleshooted every single way I know how. I guess I'm just gonna have to buy a new computer, even though the computer works fine. The pen is just, oh my gosh. Okay, we have 1 minus sine squared. So we are going to be replacing 1 minus sine square with cosine square. Okay, so we have, the top is fine. And on the bottom, we have cos squared. Sorry again for the pen malfunctioning. Okay. So now we can do some canceling. See, cos, this is technically to the first, right? Technically, I should have had a theta right there. Sorry. Add that back in. This is cos to the first. This is cos second, or squared. Remember your exponent rules from algebra. When we're dividing, we really subtract. So technically, that's 1 minus 2, which is negative 1, which would just go to the bottom, right? So basically, this top one cancels out one of these. Okay. I'm going to have to clear kind of the side work here. And I'll be writing in a red pen. So again, the top one canceled with one of the bottom coasts. So that leaves us on top just 1 plus sine theta. And on the bottom, we just have cos theta. All right, as long as your bottom is a monomial, you can split this. We're going to say this is 1 over cos plus sine over cos. All right, but 1 over cos, if you come to your reciprocal formulas, oh my gosh, this pen is just, it's not the pen. Like, this pen is brand new. Anyway, sorry, 1 over cos. Again, you might have this memorized. If not, look at the reciprocal formulas, is secant. So this is going to just be secant theta. Plus, now again, you might just have this memorized. If not, you're going to come to your quotient formulas. Sine over cos is tan. So right here, this sine over cos, because of this quotient formula, again, you might just know that one, is tan. So final answer, secant theta plus tan theta, does that match what they wanted us to prove? Yes. I've got two more on this worksheet, then I'm going to have to end the video. Well, I was probably going to end it there anyway, but I will have to restart the computer yet again for this pen. So again, sorry for the pen skipping and just being bad. Number 14, still proving or verifying. 14. We have sine over cosecant plus cosecant over secant. And this needs to equal 1. That's a theta. There we go. Okay. Well, we could do a couple different things here. We could get a common denominator, but I think that would be the long way. I would just remember or go to your cheat sheet for the reciprocals. 1 over cosecant is sine. So this cosecant on the bottom is going to flip up and be a sine. So this will be sine from the flip, and then there was already a sign there. Keep the plus. Okay. But then the secant, come to your cheat sheet, or you just know that 1 over secant, you're still in the reciprocal part of your cheat sheet, 1 over secant is cosine. So this is going to flip up and be a cos. So if you have secant on the bottom, that's a cos on the top. And on the left part, when you have cosecant on the bottom, it's a sine on the top. So this is flipping up, and it's going to be a cos for the flip times, there was a cos already there. I'm so sorry for the pen. I'm going to get through this though. Okay? Sine times sine. That would be sine squared plus cos times cos. That would be cos squared. Okay, but then go to your cheat sheet, or this has just come up so much. You probably have this memorized. Pythagorean identity, sine squared plus cos squared equals 1. So this right here is 1. And then we've proven it. Now, there were other ways to do that. We could have gotten a common denominator. That should have still worked. I just think this was easier. And thank goodness we're coming to the last one because I just don't think my pen is going to survive anymore. Might just have to type it, which, it's not the easiest typing math, but that might be what I need to do. Here is number 15. It's fraction. Ugh, okay, here. So 1 plus cos theta. I'm going to just say x, okay? Plus, and then on the top of the other one is sine theta, but again, I'm just going to say x. And it needs to equal 2 cosecant theta, but again, I'm going to say x. And then I'll come in and do the bottom of the fractions. Okay, on the bottom of the left one is sine theta, but I'm just doing x because I don't know how to type theta. And then on the bottom of the second fraction is 1 plus cos, yes. And again, it's theta, but we're just going to go x. Just make sure if you are my student that this is for explicitly sent me the sheet, just put thetas. Wherever you see x, put theta. Okay, we cannot add those fractions because they do not have a common denominator. So I'll have to go to pen for this part, I think. We'll need to invite 1 plus cos to your left up here as well, to be fair. And on your right, we'll need to invite sine and here to be fair. Okay, so now we have a big fraction. On the top, we need to FOIL this out or multiply. 1 times 1 is 1. 1 times cos is cos. I'm going to try to just type again. And then go under. 1 times cos would be another cos. And then under again, cos times cos would be cos squared. Plus, on the other fraction, on the top, sine times sine would be sine squared. And then on the bottom, you would just have one big fraction, sine x, 1 plus cos x. And I would not distribute there. Okay. So now combining like terms on the top. Well, cos plus cos, that would be 2 cos. Every time I write an X, it's just a line. It's so frustrating. This is literally a brand new pen. Oh, I've installed drivers. I've uninstalled drivers. So sorry. 2 cos x. And then this 1 can just still drop down. And then look right here, cos square plus sine square. That is the Pythagorean identity, right? Because usually I write it sine square plus cos square equals 1, but it can be switched. Cos square plus sine square is also 1. And then the bottom is fine. So I'll just type that part to save the horrific writing. And again, I would not distribute the bottom. Okay, combine like terms on the top, 1 plus 1. So that's now, I'm going to come up, I'm in pink pen. We're going to have 2 plus 2 cos x or theta. And then fraction, the bottom's fine. Okay, but look at the top. They both have a 2. So let's pull that out as a GCF. So 2 parentheses, 2 divide 2, that would be 1, plus 2 cos divide 2 would just be cos. So we pulled out the GCF. Still the bottom is fine. Okay, there we are. And then the 1 plus cos will cancel the 1 plus cos, giving us 2 over sine x. Go to your cheat sheet, look at your reciprocal. 1 over sine x is cosecant x. So the sign is going to flip up, and we're going to get 2 cosecant x. And is that what they wanted? Here's our final result. Here's what we wanted to prove or verify. We did it. Whew, so sorry for this pen. I am at my wit's end. Okay. So again, that one, we got a common denominator, fixed the top. We had that Pythagorean identity that cosine square plus sine square turned to 1. We combined like terms. We had a GCF of 2 that we factored out. We had some canceling. We had 2 over sine, but the reciprocal of sine is cosecant, giving us a final result of 2 cosecant. And that was number 15. Again, if you're my actual student that needed this piece of paper done for class, it's not X, it's theta. I just couldn't type that. Okay, sorry again for the pen issues. I hope you're having a great day and that this was helpful. Bye-bye.